All right, hello everybody. This is Mr. Parham. We are going to do another lesson, this time over significant figures. So if you can go ahead and follow these instructions, go ahead and put your phone away. That way you can focus on your video and the class. And just go ahead and complete the bell ringer in Canvas. Pause the video, do that. Once you're finished, unpause, come back, and then move on to step 2. So step 2 is to go to the presentation by going to joinpd.com and using the code at the top right. So this is PQOGZ. Go to joinpd.com and type that code in. That way you can interact with the lesson and respond, and I can give you feedback. This is a mandatory step. That way it just allows me to monitor your progress, give you feedback on responses that you give, and see where we might be struggling or where I might need to go back and reteach some things. Okay? So go ahead and do that. And then finally, step 3, make sure you get out paper and pencil to write down notes, questions, and work any example problems that we come across. Okay? So let's go ahead and jump right in. Again, this is Module 0. We're talking about measurement still. And this is now Section 4, significant figures. So we will learn what significant figures are, how to count how many significant figures there are in a number, and why they're important in chemistry. Okay? Our objective is to record measurements and calculations using the correct number of significant figures. So in chemistry, pretty much any number that you see written down in a problem or wherever is going to be the result of some measurement. So you're never going to have a number written down in chemistry that isn't associated with a measurement, such as mass or temperature or pressure or some quantity that is measured with an instrument. Okay? And whenever you take those measurements, it's important to know how precise the instrument or the tool that you used is, and how many of those digits in your calculations actually matter to your answer. So that is what significant figures will teach us. So anytime you've ever had a question about, hey, how do I round this answer? Do you want me to round it to 2 decimal places? Or what? That question can be answered using significant figures. Okay? All right, so often precision is limited by the tools available to us. So for example, if I am in the kitchen cooking dinner and I need to have a certain number of grams of an ingredient or a certain number of ounces, if I have a digital scale that will read out to the 1/100th of a gram, or like 2 decimal places, that is much better than if I have like a balance from Walmart where you just have something on one side, something on the other, and you're trying to make it balanced. It's not as precise as doing it with like a digital scale. So precision is limited by the tools available. The more precise our tool, the more decimal places we can have in our measurements, and the more significant figures we'll have. And we'll talk about what that means. Okay? So significant figures are the digits of a number that are used to express it to the required degree of accuracy. So in my kitchen example, if I have a scale that will give me measurements to the 1/100th of a gram, then I need at least 2 decimal places, or 2 digits after my decimal place, in order to express that measurement to the required degree of accuracy that my instrument is capable of obtaining. Okay, so that's what significant figures measure. So my question for you, and go ahead and pause the video and respond to this, is if you were to measure the width of this room, or the room that you're in, with a 1 meter piece of rope and with a meter stick, how would your reported measurements differ? So remember, a meter stick is going to be marked with centimeters, or with lines every centimeter, whereas a 1 meter piece of rope will not have any markings. It'll just be a piece of rope that is 1 meter in length, and that's all you'll have. Okay, so think about how your measurements would be differ. Which one would be more precise? Which one would you trust to give you a better result, and those kinds of things. So go ahead and answer that, pause, come back when you're finished. Okay. Alright, so when you're using an instrument to measure something, significant figures should include all the known digits plus 1 estimated digit. And we're going to talk about what that means. So if I'm using a ruler to measure like a metal bar or something like that, if I look at my ruler, 5 centimeters is a known digit. So I can look at my ruler and say, yep, this metal bar goes to 5 centimeters. So I can write that down for a fact. The ruler tells me that it's 5 centimeters. that is known. And then this 0.2 centimeters is also a known digit. So each of these little dashes represents 0.1 or 1/10 of a centimeter. So my metal bar goes to the second dash there. So I'm at 5.2. Both of those are known digits for my instrument. And then I want to have an estimated digit. So if I eyeball where this metal bar ends, it looks like it's kind of halfway between the second and the third dash. So this 0.05 is an estimated digit. That's what I mean whenever I say significant figures should have one estimated digit. I'm saying look at your instrument, give me all the known digits that you can. So this 5, this 2, and then give me an estimated digit on top of that. Eyeball it and kind of guess what that last digit is going to be. So that's where that 0.05 comes in. Okay, so this is another question that I would like you to respond to. Just read this ruler and give me the correct measurement for the red bar. So remember to give me all the known digits that you can spot on the ruler, and then give me an estimated digit as well. So your final answer should have, well, I'm not going to tell you. I held up my fingers. I don't know if you could see them, but I don't want to tell you. Go ahead and pause, answer the question, and then whenever you finish, unpause, and the answer's on the next slide. Okay? All right, so if you said something like 2.35 centimeters, then great job. It didn't have to be a 5 as your estimated digit because, again, the whole point of that is you eyeball it and guess that last digit. So you could have said 2.30, you could have said 2.32. Whatever it is that you guessed as that last digit is fine, as long as you had the 2, the 3, and then some estimated digit out here, then you're perfect, okay? So 2 is known because that's on our ruler, and the bar doesn't go all the way to 3. The 0.3 is known because it goes to the third dash and not the fourth, so we're going to stop at the 0.3. And then we estimate the 0.05 because it's about halfway between the third and the fourth dash. Okay? All right, so what are some of our rules for significant figures? If we just look at a number that's written down, how can we determine how many significant figures that number has, and why does it even matter? Okay? So rule number 1, any digit that's not a 0 is always significant. So if you have a number written down and there's any digit in there that's not a 0, you're going to count that as a significant digit. Okay? Zeros, they are sometimes significant. So in order to figure out when they are significant versus when they're not, we need to think about whether or not there's a decimal in the number. Okay, and so we use a method called the Atlantic-Pacific method to determine if zeros are significant or not. So I'm going to go over to the whiteboard, and this is slide number 17. I'm going to go over to the whiteboard, and I'm going to show you what I mean by this. Let me zoom out just a touch. Okay, and move this up. Perfect. All right, so on my whiteboard here, I'm going to draw a map of the United States, and it's going to be beautiful. I'm an artist, so here's my map of the United States. See that? Perfectly to scale. All right, and on the west coast, if you know a little bit about geography, on the west coast is the Pacific Ocean, and on the east coast is the Atlantic Ocean. Okay? And this is important because the first letter of each ocean will tell us something about the number that we're looking at. So if you look at your slide, decimal absent means I'm going to approach the number from the Atlantic side. Decimal present means I'm going to approach the number from the Pacific side. So what I mean from the Atlantic side, I'm going to start looking at my number from right to left. And from the Pacific side, I'm going to start looking at my number from left to right. Okay, so the third bullet point there says start on that side and go till you find a number that's not a 0. That number and every number after is significant. So just as an example, if I have the number 2.30400, and let's just throw some zeros in front of this just because, and then I have another number that is 614,017, right? Let's just throw the 3 more zeros there, so make it 614 million. I'm just making up numbers. Okay, so what this tells me is look at my number. If I have a decimal present, which I do right there, then I approach from the Pacific side. So I'm going to attack my number from the left. I'm going to stop once I hit a number that isn't a 0, and then that number and every number after is significant. So approaching from the left, that's a 0, that's a 0, I keep going, and then I hit a 2, so stop. This number and every number after is significant. So 1, 2, 3, 4, 5. We would say that this number has 6 significant figures. Okay, and then approaching from the Atlantic side, if I look at this number, the second number down here, I don't have a decimal there. My decimal is absent. So since my decimal is absent, that means I'm approaching from the Atlantic. See how they both start with A? And Atlantic, I'm going to start from the right and go left. So there's a 0, there's a 0, there's a 0, oh, there's a 7. I'm going to stop because that's not a 0. And that number plus everyone after is significant. So 1, 2, 3, 4, 5. And this one just so happens to also have 6 significant figures. All right, so that's what I mean whenever I say Atlantic-Pacific method. It's not that bad once you make the connection that decimal absent, Atlantic, decimal present, Pacific. Okay, we're going to get a lot of practice with those, so don't worry. All right, there's 2 more rules for sig figs. I'm going to call them sig figs for short. It's just more fun to say. All right, so rule number 3, placeholder zeros are not significant. Okay, to remove placeholder zeros, just rewrite that number in scientific notation, just like we did a couple lessons ago. And what I mean whenever I say placeholder zeros, I'm talking about these guys right here, or these guys right here. So any 0 that is just there as a placeholder, it's not significant. Okay. All right, and then finally, rule number 4, any counting numbers or defined constants, including conversion factors, which we'll talk about next section, have an infinite number of significant figures. So this is slide 20. Oops, sorry, I didn't mean to skip. All right, so this is slide 20, going back to my whiteboard here. What I mean by that, any counting number, so something like if I count the number of people in a Microsoft Teams meeting and there are 27 people, this is a counting number, okay? I didn't measure it with a tool, I just counted people. That means it has an infinite number of significant figures. You know, if I look at a classroom and there's 32 desks, that's a counting number. Okay, I didn't measure it with a tool, I just counted. That means it has an infinite number of significant figures. If I say that I'm not, but if I say that I'm 6 feet tall, now all of a sudden this is not a counting number. This is a measurement, so I'd say it has 1 sig fig. Okay? But if there's 3 people in a room, and I say that there are 6 feet in this room, now it's a counting number. See that? So this has infinite significant figures. So if I say something is 6 feet tall, measurement. If I say that there are 6 feet in this room because there's 3 people with 2 feet each, that's a counting number. That's significant. All right, so I'm just throwing that out there. Okay. So go ahead and answer this question too. So I want you to try these examples. How many significant figures are in the following numbers? So here are the Atlantic ones. These are where the decimal is absent. So remember, Atlantic, you're going to approach the number from the right, from where the Atlantic Ocean is. Stop whenever you hit a number that's not a 0, and then every number after it, including the number you stopped at, is significant. Okay? Go ahead and pause and do those, and then I'll give you feedback on your answers. Okay? Alright, so a couple things to consider. Whenever you're doing calculations in this class, calculators are not aware of significant figures. A calculator will give you an answer to like 15 decimal places, and it just doesn't care about significant figures. So it's up to you, as the person doing the math, to decide how many significant figures you need in your answer. So to do that, we're going to round, right? So answers should not have more significant figures than the original data. with the fewest figures, and they should be rounded. So we're going to talk about how to figure out how many sig figs I need for adding and subtracting here in just a sec. Okay, so rules for rounding. Rule number 1, if the digit to the right of the last significant figure is less than 5, then don't change the last significant figure. So what that's saying is, this is slide 25. What that's saying is, if I want to round the number 8.71, and let's say that I want to round it off right here, this is my last significant figure, I look at this number, it's less than 5, so the way I round this is just 8.7. Okay, so that's saying don't change the last significant figure if the number that comes after it is less than 5. Alright, rule number 2, if the digit to the right is greater than 5, then round up to the last significant figure. So looking back at our example, if that number was 8.76, okay, if that number was 8.76 and this was my last significant figure, then looking at the 6 is greater than 5. So now I would round that up to 8.8. Okay, I would round that up to 8.8 because the number that comes after my last significant figure is greater than 5. So you round up. Okay, next. So what I want you to do now is round each number to 4 significant figures. So we need to count the number of significant figures in each number. Okay, so let's just go ahead and show for the first example, and then you can do the next two. So if I'm looking at the first number here, I'm just going to bring it down here so I have more room. That's not a 5, that's a 4. Okay, so if I'm looking at the first number, first thing I have to ask myself is, do I have a decimal? And the answer to that question is yes. There it is. So I have, my decimal is present. Present means that I come in from the Pacific. So present equals Pacific. And remember, Pacific is coming from the left. So I'm going to attack from the left, right? And let me attack with a different color, that way it stands out. I'm going to attack from the left, and I hit a 2. I should stop because that's not a 0. That number and every number after is significant. So 1, 2, 3, 4, 5. Okay. So my question says to round it off to 4 significant digits. That means I'm going to cut off my number here, and I'm going to evaluate this number to see if I round up or down. So 4 is less than 5. That means I'm going to round down. And so my final answer would be 256. Sorry, I accidentally drew a decimal there. Is 256.7. That's my answer, rounded to 4 significant figures. Alright, so try these and go ahead and respond to those. I'll give you feedback and come back whenever you're finished. Alright, and then go ahead and take a moment now that you're back to drag your dot to how you're feeling. If you're feeling good about significant figures so far, just go to the green. Otherwise, go to yellow or red, and I will ask you if I can help or if you have any questions. Okay? Alright. So how are we going to add and subtract, considering significant figures? How are we going to do that? So there's a couple rules. So number 1 is you want to round your numbers so that all numbers have the same number of digits to the right of the decimal. In other words, you want the fewest number of decimal places possible based on the numbers that you start with. So that's how you're going to do addition and subtraction. So for example, this is slide number 30. So for example, if I'm going to add the numbers 42.1 and 16.875, my answer is going to be, if I don't round, my answer is going to be 58.975. But this rule tells me I want the fewest number of decimal places. And so I have to look at the numbers that I started with and say, all right, which one had the fewest number of decimal places? Well, this one, 42.1, only has 1 decimal place. whereas this one has 3 decimal places. So my answer should have 1 decimal place. That means I need to round off here and look at this number to decide if I round up or down. So once I round that, I'll get, if I round that 9 up to a 0, that means that my 1 gets carried over there. And it's going to be 59.0. Okay, so that would be my answer in that question. So again, if your 9 rounds up to a 10, you carry the 1 in the next place over. All right, so that would be my answer for that one. Okay, my next rule for multiplying and dividing, if I'm multiplying and dividing numbers, I need to round the answer to the same number of significant figures as the original measurement that had the fewest. So now I'm not necessarily looking at decimal places like I'm doing with adding and subtracting. I'm looking at total significant figures. Okay, so an example of that might be, if I'm multiplying 3 times, let's say, like 15.50000. Look at how many significant figures each of these numbers have, right? This number has a decimal. So if I approach from the left, I stop here. And so every number after it is significant. This number has 1, 2, 3, 4, 5, 6, 7 significant figures. This number does not have a decimal here. So I'm going to come in from the Atlantic, decimal absent, Atlantic, and I'll stop here. This number only has 1 significant figure. Guess what? That means my answer should only have 1 significant figure. So if I don't round, I'll get something like 46.50000. That's if I don't round. But since I only need 1 significant figure in my answer, guess what? I'm going to cut my answer off here, and I'm going to evaluate this number to see if I go up or down. So 6 is greater than 5. That means I'm going to round up. And so my final answer would actually be just 50. It has 1 significant figure, which is just exactly what I need. All right, so adding and subtracting, look at decimal places. Multiplying and dividing, look at significant figures. Okay, those are the rules. Oops, I don't want Siri. Okay. All right, so go ahead and try and solve these. Remember, adding and subtracting, round off based on your decimal places, whichever one has the fewest. Multiplying, round off based on your sig figs, whichever one has the fewest. So go ahead and pause, answer these, and come back when you're done. Okay, and then we are finished with that lesson. So I want to go ahead and ask you these questions. So this is multiple choice. What is the correct measurement of the green bar? Take a second. Remember, you want to get all of your known digits plus an estimated digit. So go ahead and pause, answer this one. I'll give you your feedback as you do it. And if you said C, great job. So 82 is known there. 0.9 is known because this is the 9th dash. And then we estimate that it's right on that dash, so we're going to just throw that 0 on there to show that it doesn't go any further beyond that. Okay? And then lastly, determine the number of significant figures in each of the following numbers. So go ahead and pause and do that. And then unpause whenever you're finished. I'm going to go ahead and go to the next slide, so make sure you're done. Okay? And if you said 2, 4, and 1, great job. Remember, decimals absent, coming from the Atlantic. 0, 0, oh, there's a 2, I stop. So those 2 numbers are significant. Decimals present, so I come in from the Pacific. Oh, there's a 7, so I need to stop. Those 4 are significant. And then decimal present, coming from the Pacific. 0, 0, oh, there's a 1, I stop. And that's the only one that's significant. Okay? Alright, so I hope that lesson made sense. If you have any questions, go ahead and ask them here. If we're doing this live virtually, then come back into the Teams chat and ask questions if you have them. Next thing, of course, is complete the exit ticket, complete the assignment. This says it's going to be due 9/4. That is incorrect because 9/4 is today, and we got a late start on this lesson, so it's actually due whenever we come back from Labor Day weekend. It's going to be due on 9/8. Okay? So thank you for watching. I hope it made sense. If it doesn't, of course, ask me questions any way you can contact me, And I hope you all have a great rest of your day.